So the police got back to me. Yeah, they said they talked to the adults, and they said they have no CCTV in that area, which I kind of don't believe. Or like cameras are just there, they're not real cameras. It was only like 36 hours after the event that the cops were in there. So it should have had at least 48 hours, 2 hours.
How can I use this?
No, this is
Yeah, last night, by the way,
Yeah.
there was a guy calling us to dinner. He was just like, you know, would it make you to go to the ATM and get some money? Right. He's just like, and he was like crawling up behind us, constantly chasing us for about a block. Yeah. And I mean, I was getting ready to turn off. I was just like, this is right.
Okay.
Continuously approaching in the person's face, and I don't trust it.
Oh, it's a razor.
Okay. Thank
So,
you. Thank you for
more than you.
Oh, here. Oh, sorry, here. Oh, okay, we should get started. Hello, welcome to the DMM working group. I'm Sri Gandavalli.
I'm Satoru Matsushima from Japan.
Okay, so this is the agenda for today. First thing, please be familiar with the IPR statement. And the next one is the note well. We all are familiar with the note well. Please be aware of, please read the note well statement. This document is, this meeting is governed under certain rules. Please be familiar with these rules. And before, we don't need the blue sheets anymore. Yeah, we want a note taker, please. Any volunteer? Nobody's there. Any volunteer? We should just take. John, thank you so much. Okay, a quick update on the document status. Yes, Suresh. So the first one, these are the working group documents. First one is segment routing for IPv6 for mobile user plane. This has finished the working group last call, and it's with the area director. You can ask for status later. Next one is the mobility aware transport network slicing for 5G. We have a presentation coming out from John and team. Next one is user plane protocol analysis for 3GP 5G system. Not much update on this, but we'll get a status update on this. So first thing, I think we can start with John's presentation. This is the mobility aware transport network slicing for 5G. Just not the slides. What is not the slides? How do I go into that?
It's close the tab. Which one? Stop the sharing.
So thanks. This is the a fifth revision of the mobile
Bit closer, John.
closer.
Yeah.
Okay, I thought there was too much echo, or maybe not.
Okay, maybe just balance it out.
Is it okay? So this is the fifth revision we've made of the working group draft, the mobile aware transport network slicing. Let me see if the clicker works or does not work.
Yeah, I can move the slides.
Okay. So if we go to the next slide, please. So the document is generally very stable. We're really working with addressing the comments and basically all the comments that we've received in the last meeting. So I'll just go through that. So I've divided into four sections really. The major comments were really to align the terminology and the concepts to the T's network slices work. And we've done a lot of work to align with the T's framework, using the terminology, the concepts, and even working with the folks who are on the framework draft. So I'll get into that on the next few pages. The other one was to address a relation to the 3GPP functions, and we've clarified that we're not modifying or changing any of the 3GPP functions. We're only relating it to how the user plane is, or the transport network is setting up the slices. And I guess the third one was a broad comment to to have the text in the draft read more consistently. And to that extent, I think we've made significant. We'll go through it, and we made changes throughout the draft actually on that. So let me go to the next page, please. So this is just a reference to the abstract section to show that we are addressing the comments that were received. So fundamentally, the changes in T's terminology, we've changed the terminology to use customer, so the 3GPP customer, to an IETF slice provider with an intermediate network in between, which is the specific use case that we're addressing. So that's updated in the abstract, but also in the rest of the document to cover the whole thing. The rest are details. I think you'll have to read the draft, but I'll be able to clarify questions on this or anywhere else. So if you go to the next page. Right. On this one, again, it's again, the major comment that we're addressing is the T's terminology. So there was not that much to change per se in the figure itself. Basically, we were using an SDN controller, SDNC, and the T's terminology refers to it as a network controller. I think there is a one-to-one correspondence, but the specific use is of network controller. And then the others we refer to it as a transport network function in the 5G management plane. But what T's generally refers to is an orchestrator, and we've called it the transport network orchestrator here. So I think it's pretty well aligned now in terms of the terminology and the text. So if we go to the next page, please. Right. So here, I think we're getting into the specifics of the draft. And, what we're covering in the draft is that this is a scenario where there is an attachment circuit in between the 3GPP customer, which is the requester of the slice, and the provider, which is the transport, IETF transport provider. And, we also go into the service demarcation points, I mean, where those are. And so if I go to the next, so I'm going to the next bullet, actually. Again, we clarify the TNO being a logical entity that can be a part of the NSSF, but we don't get into describing what it is. That is, in 3GPP. And then we also clarified how the UDP port information is provided from the slice establishment to the management plane, because that was the part that we need to address in terms of how it's populated to how the user plane works. I mean, which is what we're describing this draft. And the next slide, please. Yeah, I think the changes were in terms of really terminology and the concepts in T's, and also the 3GPP related aspects to how it works. I believe that now we've addressed each of those comments and also made a thorough change in the draft to make it read consistently. It's also aligned with, so T's is actually working on some other uses of the slice, and this becomes, it's fully aligned with that. This is one of the cases where the the service demarcation point and the customer requesting it are separate. And so they have other cases which they use layer 2 and other things. So this becomes one of the many ways in which you can configure slices. And I think it is ready to progress, but we need reviews from the group, and we'd be happy to, address comments as they come. That's where we are. So I'd really like to request for reviews and then see how we can proceed.
Thank you, John. Any questions, comments? Yeah, please. Yeah.
Kenji from CMCC. I haven't read through the whole details of the draft, but I just wondering because yesterday I was thinking one thing from the five and the 3GPP 5G part, and then you have another slicing on the access. And then from the access G0B to the UPS there is the IP network. I've been thinking about, like you have a slice and then allocated through like SNSAI, those type of things. Then how are you going to map? Maybe you have already specified, just to ask, how are you going to map from the like AS group or those NR slides to the IETF slides?
Right.
Yeah, so thank you.
Right. I think this page is pretty good for that. So the way to map, I think in 3GPP itself is specified in 28541. There's VLAN, MPLS segments, and other mechanisms by which you configure the port in the transport plane. The specific one that we are proposing here is to use a UDP port because, and that's an addition, we've also mentioned that in the document, in the draft, because if you look at the figure on the right, if you have the customer edge and the provider edge separated by an attachment circuit, then you need to be able to convey that via those IP semantics. So that is covered in the draft. That's the user plane part. Your question was more like, how does the 3GPP network provision it to the G node B or the UPF, right?
No, not on that part. Things like, I suppose on the G0B, at that moment toward the GTP side, N3 interface. And then that one is like for the 3GPP, it's like overlay, while IP is the underlay. Here you are, I assume you are trying to provision or define a IP-based NR, the slice, well to match for the NR slice that being allocated by the 3GPP side. So the G0B at that moment, right, about N3, there must be some way to map. I think you just explained by introduce the UDP port. Okay, well, I haven't read part, but yeah.
Yeah, I think you're mentioning, if I understand, let me see if I understand it fully. you're mentioning that in 3GPP, it's the GTP connection between,
Yes, exactly. GNOB and the
Right.
UPF on the N3, and then but the IP is I assume you're trying to do the underlay on for the IP side. So, but you have to map from the 3GPP slice to the IP slice. Otherwise, you cannot like do the guarantee of
Right.
testing.
no, I think it's covered in the draft, but I'd advise you to, so just a very brief explanation is that the GTP is configured via the SMF, via the N4 and the N2 interfaces. So the IP address corresponds to the what is provisioned via GTP. So there is a correspondence there. But please comment on that, and I'll rectify.
Just a comment to the Arnulf Link Nokia. Just a comment to the previous question. This is an active discussion in TES working group. So they have a draft on this mapping
Ah.
between 3GPP slides to IETF slide.
Okay.
So I think it's work in progress.
Okay, so
Thank you, Hannah.
thank you. I'll refer to that as well then.
Any other questions, comments? Okay, so I think, John, I think you asked for the reviews, right? I think you also have a chair review pending. We'll also just do some initial, both Satoru, myself, and even Stefan also.
Thank
We'll
you.
do some initial reviews and also as a working group to do the reviews, right?
Thank you.
So we can do that. So yeah, again, on the mailing list, we need some more discussion, I think, on this. Yeah, that's this. Moving on to the next topic. Yeah, I think the next one is, 1 second. Sorry. Yeah, you just integrating, but before the failure status. So I think the next one, we wanted to get an update on the SRv6 document. Eric, on the SRv6, do you want to say a few things on where we stand and it's just quick status update, 1 minute? On the user plane, yeah. Because it's in your,
Yeah, so the DMM SRv6 user plane document is in IETF last call, I think. The same objection about it being proposed standard resurfaced. Joel's concerned about interfering in 3GPP architecture space. I had thought that changing the some sections to be informational might have addressed that. He told me the other day that changing the entire document informational would address it. That just changing the sections did not somehow. So I have reached out to the 3GPP coordination team and Lionel from CT, who I think is what are they called, chairs or rapporteurs or whatever?
he's right there.
Yeah. Okay. So you're presenting in the next coordination meeting after this about the status, or sorry, about our inquiry to CT4 about whether or not it conflicts or it impinges upon 3GPP architecture. So otherwise, I think there have been generally no other comments in the IETF last call. So I don't know what happened during the telechat, but this is, I think, the only issue to be resolved one way or the other. So just waiting to see how this plays out. I have no personal preference for informational versus PS. The IONA registry affected is first come, first serve. So, I mean, you could write it on the back of a napkin and get your number, so it's fine. But I did, you know, like I was hoping we could accommodate the wishes of the authors and the concerns of others, but maybe there's just no way to do that. So, you know, do you want to maybe correct all my misprint? Yeah.
Thank you, Lionel. Yeah, from the 3GPP side, so first of all, we had the same comment saying that why it was proposed as a proposed standard, saying that it was, at least at this time, only for information, because we are not even sure that how it will actually map with the ongoing work within 3GPP and so on. So I think it's fine. The other aspect was that it was requesting for some review from 3GPP, and as I said, CT4 is the main group. We had already an activity on that. So this message was sent to 3GPP. So I don't know if anyone will comment that. And my point would be for you to know what would be the next step, if whether it is informational or proposed standard, what would be the next step for this, and especially with any coordination with 3GPP and these aspects. So maybe go on or resume the study that we had on this topic in CT4.
Right. Yeah, thank you, Lionel, for that feedback. It helps. I think from the chair's point of view, at least, me alone, because Sato is a co-author. So me and from Depeng's side, I think we made sure that at least based on the feedback that we got from the working group, we tried to make sure we are in no part of the specification says we are overwriting what 3GPP says in 23501 or whatever document, right? It's an IETF specification, completely no way it affects or impacts the 3GPP spec. That we made sure. But in somewhere, if any of the text is not aligned with that thought, then we should fix it. I think that's point number one. Point number two, I think with respect to informational, we, based on Joel's early feedback, authors have agreed to pretty much comply to what he asked for, right? Now, if the new request is to make the entire document informational, I don't have a position on that. I'll let authors and, AD really, figure out the next steps on that. So, Suresh.
Yeah, hi, Suresh Krishnan. So, Lynn, just to give you some perspective on the draft, right? Like I've been following the draft versions and so on. So there's like parts in the draft that actually work within the architecture itself, right? So it says like, okay, like, you have the SMF, you have the UPF, and this is how we can put other functions around it to stop the connection between them. And there's parts where it says like, hey, you can do better than the other architecture. I think that's the parts that have been moved to informational because it kind of doesn't fit the architecture. So that's where we are. So there is like changes in the draft that has happened like since the last time I read it. Like I read like version 7 or 8 or so. Now it's in the 21 or something, right? Like, so it's been changed a bit, but we need to still discuss it and see how things go. But that's the perspective. So there's stuff in the draft that's inside the architecture, coloring inside the lines and outside as well. Okay.
Yeah, one last thing is with other than one particular feedback, generally the working group is okay with the document. We haven't seen much any major feedback, so hopefully we'll be able to close this one issue, and move on. Yes.
Hannu Flink, Nokia. The schedule of the last call is not clear to me. I have seen the mail that a couple of weeks. What are the exact dates now?
That's true.
Because we are preparing also our response.
Eric, you want to put a deadline on that? I think somewhere even
I know the time, so I looked at it. So so Hannu, so usually the last call is 2 weeks, right? But since we are an IETF week, it's going to be 3 weeks. I think it's November 23rd is the last date on the last call.
I think maybe it's good to put a date and send an email. I think that
it is in the last call. So the last call does say November 23rd.
Thank you. All right. Thank you so much. Next, we move on to the Eric. So this is a new proposal, discussions on integrating AN and UPF. Jeff.
Okay, so this is the follow-up discussions on the idea of integrating AN and UPF. We're now at version 2 of this draft. We have a new co-author, Kashif Islam from Red Hat. Next slide, please. So I want to give a brief review of this basic idea. In 5G, UPF are more and more distributed and close to the Geno BCU. And in the meantime, the RAN decomposition is moving the CU towards the core side. So now they meet in this edge data center. They become co-located, and often, if they are implemented by software, they may be running on the same server, but still they are separate functions per current 3GPP architecture. So what if in 6G we actually integrate the AN/CU function and the UPF function into a single function? If we did that, we get a flattened routing switching based architecture where this integrated device with what we call the NUP. It's basically a router or a switch that has wireless and wired connections. Just like that, IEEE technologies gives you the Ethernet connection to a router. Wi-Fi technology gives you a Wi-Fi connection to a router. And now we have 3GPP technology giving a mobile wireless connection to a router. And the rest is just routing switching per IETF, IEEE standards. And all the services or the features we have deployed for wireline networks, IPVPN, EVPN, whatever, can be just applicable to the wireless network. So that's the basic idea. Next slide, please. So the work will need to be done in 3GPP. It's not IETF work, but we are using this DMM venue to discuss the idea, hoping to get feedback, and especially from mobile operators, to see if this idea makes sense. If it does make sense, if the operator wants to see this deployed, then we can bring this to 3GPP for further discussion for standardization there. So this is a picture that shows the idea. Today we have the UE and connecting to RU, DU, CU, and then eventually the UPF. Being distributed UPF, that means that the data network that UPF connects to also needs to be distributed. And that means that the data network needs to be connected together by VPN. So now, if you click, just click, yeah. So between the UE and CU, we have the UE's IP or Ethernet traffic on top of radio stack, and then click.
There's a PDF actually.
Yeah, okay. Yeah, and then between the CU and UPF, it's the same UE traffic in the GTPU tunnel. And next, the CU just does the relay. The CU does not do routing at all. It just does relay. And next. So we talk about the CU, UPF, and also the PE for the DMVPN. The context is they are collocated in the same data center. And what if we combine them into a single device? Click on to the next one.
So if I may ask a question, right? So how is the mobility going to work if you're bringing UPF so close to the CU?
The mobility and handling, it does not change. So today, with distributed UPF, it's supposed to handle handle mobility already. All we're doing here is put them into the single function. We're not changing any function. Yeah. Next. That's good. Continue. So now that NUP1 is a combination of CU1, UPF1, and PU1. NUP2 is a combination of the CU2, UPF2. Now the radio protocol stack comes from UE1 to NUP1 directly. And then the NUP1 just does the routing or switching there to the local data network or to the remote VPN site. That's the basic idea. I can.
Hello. A question, Hannu Flink, Nokia. What prohibits to do this already now? Isn't this a deployment issue? What changes if you integrate these functions into single data center or single box?
What changes? It would involve signaling changes. I'll have a slide on that one. We talked about this already, so skip to the next one. So the advantage is that we now have a simplified signaling and optimized data plan. Before, I counted that to establish that N3 tunneling between the GNOB CU and UPF, even if they are running on the same server, but being separate function, you need signaling to establish that tunnel. And it involves 7 steps, 4 network functions, 3 signaling interfaces. Now that is all gone. And also, before you need to, the GNOB CU need to put on GTPU header and immediately taking off by the UPF that is running on the same server. So that brings in, now that is not needed anymore. That brings in the performance improvement, especially when you are doing this on servers using software implementation. That's a big win there.
Your question, Suresh?
Yeah, I do, Suresh Krishnan. So I think I think other than the things Sri brought up, right? I think like and Hanu actually brought it up as well. But let's say you hand off between two G-Node Bs, right? So right now you can use like a vertical handover to kind of use a sideways interface like X2 or like whatever is a replacement for that to actually send back to the same UPF. Because the UPF is your IP point of presence, right? Now, if you combine it, then your IP point of presence is going to change. Your IP address is going to change, right? If you hand off to a new G-Node B, right?
Right. Remember, the context is that you already have distributed UPF and the CU together in the same edge data center. So what you're talking about,
let's say you go
needs
to
to
another,
be handled by the current separate CU and UPF already.
okay, so
that is not changed.
So your assumption is that there's going to be multiple RRUs like that are distributed and they'll end up at the same CU. Is that your base assumption?
Right. That does not change. This.
No, it's not. It's not that it doesn't change. You need to state that as an assumption because it was not clear, like from your presentation, that that's an assumption, right? So like put that in. And the second thing is like if you look at like how the SMF talks to the UPF, right? How the session set up, how the quality of service is set up. It's based on the TEID. Okay.
Yes.
So now we're getting rid of the TEID. So you're going to come up with a whole policy control architecture for this, right? Because that's gone. Because if you have the CU directly with the UPF, there's no tunnels to differentiate the things in there. So this is all input to you. Like, just think about it. I don't want you to give an answer because it's a difficult answer. But if you're going to change that, you're not just changing the architecture for the data plane, but you're also changing the policy control architecture.
Thank you. Indeed, that needs to be changed. I actually mentioned it in the previous IETF presentation. It does involve changes in the signaling plane. However, we are talking about 6G. I'm pretty sure even if we didn't make this change, there will be big changes coming in that, right? So indeed, the changes will happen. And in this case, if it does happen, it brings in the simplified signaling. Yeah.
John?
Hi, John from FutureWay. I have a similar question as Hanu and to an extent what Suresh asked about the TEID and QoS. My understanding is that the biggest challenges are with QoS and how that is sent to the G-Node B, and just putting it together as one function will not change those dynamics. And it's all those queuing delays and so on that needs to be optimized. So I have the same opinion as Hanu that putting it together is possible today. So combining it takes away the flexibility of separating it, while it does not address the queuing related aspects of, for example, if you have QFIs that are mapped into specific entities in the G-Node B, all of those issues still need to be solved if we want to get better streamlining. So it's a comment that
Okay, so in previous IETF, I have a slide talking about the QoS aspects. So in this one, I didn't have a slide for that. I will follow up with you to see if what I talked about last time that already addresses that. If not, I will add more discussions there. But here, so far, this is just a review part. If you go to the next slide. So in this new reversion, we added quite a few discussion points. The following slides are basically for those discussion points one by one. So let's just skip this one. Let's just go to the specific slides. Yeah.
But I did notice the NAT here. So in 6G, you plan to use NAT? No, no dependency.
Okay. So we already talked about simplified signaling last time and then earlier. Here, I added this red text there. This is what I learned from an operator recently. So it turns out that we not only need to establish the N3 tunnel when it is first brought up, we actually need to periodically refresh the signaling to maintain it. Turns out that is a big performance hit in the control plane. So by doing this, getting rid of the N3 tunneling when it is not needed, we also remove that periodic refreshes entirely. So that's another point I want to add here. Next slide, please.
You're not talking about the GTP.
GTPU.
GTPU path,
Yeah.
path messages.
Right. Yeah. One point that came up is about net. So an operator, a large operator may have many regions, then they use the same private address space across those different regions. So today they have, in that case, they have a net gateway attached to each central UPF. And then so the UE to internet traffic goes through that net gateway. UE to UE traffic, if it's intra-region, does not go through net. UE to UE traffic, if it's inter-region, then it goes through the net gateway twice, right? So the question was, what happens if you do use integrate the NUP in that situation? And the answer is that even before you have the NUP, as long as you use distributed UPF, you have the same problem that you need to solve already. And the solution is actually the same. So basically, in each region, you have many distributed UPFs, but you will have a central router in the data network. And that central, the hub router will have a gateway attached. And again, the UE to internet traffic goes through that net gateway. UE to UE inter-region traffic goes through two gateways. And that already needs to happen with distributed UPF. And adding the, replacing that, integrating the UPF and CU together into NUP does not change that. It's same thing will still work. So next. What about ULCL IUPF for Mac? So for edge computing, one way to do the traffic local breakout is use this uplink classifier IUPF. That is today with 5G, even with central UPF deployment, you can do that already. But it is a special and extra user plane function. It sits in the path of the N3 tunnels, and it examines all the N3 traffic. And then it intercepts some traffic for local breakout purpose reason based on the filtering rules signaled from SMF. So in that case, the CU puts on the GTU encapsulation, and then all those traffic with the GTU header will be examined by this ULCL IUPF, and then some of them be locally routed. So that's a waste of your processing power that is already avoided by even by distributed UPF. And replacing the distributed UPF with NUP does not change that. So basically, in the target scenario for the AM, for NUP, where you have distributed UPF colloquially with the AN or CU, then you do not need the ULCL UPF already. And switching to integrate NUP does not change that. Next slide. What some people are worried about that now the AN does more work. It's increased the burden. You may overpower it. But notice that the context of this is that we have the CU, UPF, and PE co-located in the same edge data center. Whether you do it separately or integratedly, the same thing need to happen no matter what, whether in separated functions or either in these integrated functions. And in case of a cloud native implementation, whether it's the work to be done on the AN, UPF, NUP does not matter. In fact, for capacity planning purposes, it may be easier Because before you had to figure out, okay, I'm going to allocate how much compute resource for the CU function, and I need to figure out how much compute resource I allocate for the UPF function. Now you don't have the UPF anymore. You just have the NUP, and you just need to figure out which PDU sessions will be assigned to which NUP, and that's it. Everything will just, the rest is done. Next slide, please. And another question is, now the AI needs to do more, it becomes more complicated. For that, I want to point one fact today. So today on the CU, where we put on the GPU header and send it to the UPF, that is actually already performing the PE functionality. So you think of this, forget about mobile, forget about wireless network for one moment. Just think about VPN technology in IETF, in the wireline. We have this concept of hub and spoke VPN, and we have the concept of per prefix VPN label. So you have the spoke PE connecting to some CE, and you can advertise per prefix label. So that when you get a traffic with the per prefix VPN label, you don't need to do IP lookup anymore. You, based on the VPN label, you know exactly which CE to send traffic to. And that's exactly what this CU does here. So the GPU tunnel corresponds to the VPN label stack. Today on the CU, there is no IP processing because there is no need for IP lookup, because all the uplink traffic goes to the central UPF. All the downlink traffic, you have the TE-ID that tells you which UE it is for. That TE-ID is just like the per prefix VPN label. So today, all that is different from the IP VPN in the wireline case is that we don't have a VRF on the CU to do the IP lookup. But now, for the purpose of edge computing or local internet breakout, we want to do the local routing on the CU there, in the edge data center there. So we can put a local VRF there for that purpose. And remember one thing, that today routing functions are actually being commoditized. It's not difficult to add routing function to anymore. So consider the co-located CU, UPF, and PE, and consider the benefit of simplified signaling and optimized data plan. It makes sense, it's feasible to have this combined function here that does everything. Yeah. Next. I think this is the final slide here. So one question I got was, isn't this against microservice architecture? Because with microservice, you're breaking up everything. And here you're combining everything. You're going against the trend. So I looked up the microservices. I found this on internet. It says microservices architecture style that structures an application as a collection of services. And the microservice architecture enables the rapid, frequent, and reliable delivery for large, complex applications. So to me, it is about decomposing complex applications. Here, NUP is about integrating forwarding functions for the purpose of high performance data forwarding. I don't think that in our case, we want to go with the microservice architecture here. That's my view. It's for different things. So, yeah. Next, I think I have one more slide. Yeah. So basically, I bring this to this forum for discussion. I appreciate that all the comments I get, and I want to see that if you're interested in this, talk to your colleagues on your wireless side to see this if makes sense to them as well.
Hannu?
Thanks.
Yeah. Hannu Flink, Nokia. Yes, I recognize that there are some merits in this proposal, but still some details are not clear to me. For instance, multi-access. How would you support multi-access with this?
Multi-access. So if you look at this picture, we are basically just combining those separate functions together. So whatever multi-access functions you need in a separate architecture, the same should happen here. But let me follow up with you offline on that.
Okay,
yeah.
Thank you.
Yeah, thanks.
Okay. Marco?
Marco Liebschenisi. Thanks a lot for this very interesting draft and discussion. So I really like it. But as you said, it's pretty much 3GPP specific. It discusses 3GPP functions, reference points, and as you correctly said, well, if there is acceptance of this, then you need to bring it to 3GPP. So for the IETF, if we deploy something like an ANOP, do you expect any kind of changes on the remaining interfaces which have not so spotted here, which is between the UPF and any access application service, which is N6, right? Is it working as today, or do you expect something that the IETF could do in terms of traffic steering from the service to the correct ANOP?
There is no change on IETF's side that needed for this proposal. The reason I'm talking about it here is to gather feedback and ideally support from the mobile operators and vendors first. Only if I get enough support from them, then I have a chance to get it accepted in 3GPP. If I don't even get support from the operators or from the people who are familiar with and friendly with IETF technologies, there is no chance I can get it accepted on the 3GPP side. So that's why I'm talking about here. Okay. Indeed, the work will need to be done in 3GPP, but I'm just trying to first socialize this idea among people who are familiar with and friendly with IETF and wireline technologies.
Okay, because some early aspects of DMM could be brought in here, right? If we deploy something like an ANOP and we consider session continuity when moving from one ANOP to another one, you could do something with traffic steering, unless you treat the previously assigned ANOP as an anchor and remain anchored there until you change the IP address of the user equipment. But okay, thanks for the clarification.
Thanks.
Satoru Matsushima, SoftBank. Thank you very much for interesting discussion. Just a comment. When we see the structure of the 3GPP organization, we can see the LAN, we can see the SA, we can see the CT. That's the very fundamental architecture, actually. So all of the ecosystem follow that architecture right now. So your proposal seems that collapse, that's fundamental architecture, but it's really interesting for further architecture consideration.
Yeah, it's indeed a big change. I don't know it will happen or not, but I'm just trying to see if we can get feedback and support first, and then bring to 3GPP. Yeah.
Lionel?
Lionel Moreau. Yes, early feedback from a 3GPP point of view. Actually, it would be seen only as a deployment option. So, for instance, today you can deploy the private mobile networks using this configuration if you want. You can even encapsulate all the radio parts. It will be a black box for them. The only thing that will matter is the link between the UE in the box and the rest, whatever the rest. So, if it is something that need to be bring to IETF, it's something that you need to highlight what need to be changed according to the existing specification. What needs to be enhanced or added. And after that, I would be agree with Marco, is that if actually you use this configuration to add more DMM related functionalities, it would be more an IETF matter than a 3GPP matter. So for instance, we have already cases for UPF, SMF collocation, UPF, IMF collocation, but from an architecture point of view, it's not really relevant from a 3GPP. We're just speaking about the functionalities, the signaling, but what anything regarding the deployments, it's really for the vendor side or for the operator side.
Right. So for the co-location, indeed does not involve any changes at all. But by integrating them, if you want to simplify the signaling part, then that indeed does involve 3GPP changes, and that indeed needs to be accepted by 3GPP for it to happen at all. So that's the part that we will need to bring to 3GPP after we get support.
Yeah. If I may, not really. If you said everything is in a box, whatever the type of box, what's happened in the box, it's only relevant to the vendor or to the operator. You don't have to comply always to the signaling defined in the specification. So if you have some signaling between the CU, UPF or UPF or something inside the box, it's not really relevant.
But
So,
today you have separate signaling to the CU and UPF. And then I counted 7 steps to establish that N3 tunneling there.
And
that could be removed by signaling changes.
And it's why I'm saying, so it could be relevant in that case, but from a 3GPP point of view, we really don't care. The only thing that will matter in that case is that what's come from the DU and what's come out from the UPF. If everything is fine there, you can do whatever you want. For instance, I have example where we are using mesh architecture and so on, mesh signaling in a box, even if it is not defined by 3GPP, but as long as you have everything good for the input and the output, it's up to your implementation.
But here, I should have drawn the AMF and SMF in this picture, because today there's N2 signaling between AMF and CU, and N4 signaling between SMF and UPF. That part can be simplified so that you don't have to have those 7 steps of the signaling to establish a tunnel between the 2 software entities running on the same server. That part could be optimized.
Okay, last comment on this, Suresh?
I think TNG is like remote.
Jeff, not the first time I heard this one. You know, besides the technical part, I truly suggest you bring this one to 3GPP first to discuss there, since no matter what you're going to achieve here, and the final call is still there. So thank you.
Suresh?
Yeah, thanks, TNG. So I think the feedback you should take, like at least like from everybody, like, you know, like what Hanu said, like Marco said, like, you know, John said, and Lionel said as well, right? So this is possible today. So if your thing is like the other thing should not be possible, I think you're going to face like an uphill task in 3GPP, right? So to give you an example, right, there's SMF and UPF, right? So they got an N4 in between with PFCP. There's like, I've seen like hundreds of networks where they're in the same box and there's no externally visible N4 interface. They use some kind of internal things. If you do that the same way as an implementation, like combine this to have your implementation be more performant, that's fine. But it should still have the same IEs on the N4. And if it's able to look at the TEID and map it to some internal thing that you do, everything should work as is. I think that's like what Lionel is pointing to, and I think Hanu did as well before, to say this is possible today. So, but if your point is to take away the other option where it's like not co-located, I think that's going to be a harder sell than that. So I think that's the feedback you should take from this discussion. There's nothing saying this is bad, but this is not like a win only. So there's losses, right? On the mobility front, you lose, like you probably do like more handovers than needed. So there's all, and the policy control changes. So I think you need to balance these two. Having this as an option is interesting. Having this as the only option, probably not.
Thank you. So I have 2 clarifications here. This is not the only option. The NAP can still do the N3 tunneling to a separate UPF when it is needed. Secondly, indeed, with today's separate signaling, N2 and N4 signaling, this can be done in the same box with internal optimization. However, I still see that the signaling, the separate signaling could be simplified. Instead of doing 7-step signaling, involving 4 network functions and three interfaces, we only need to involve 2 network functions and 2 steps. I think that is a optimization that I would like to see accepted as in 3GPP said, but indeed, this needs to be discussed in 3GPP. And I'm actually going to Toulouse next week.
Okay.
And
Thank
start socializing there as well.
Okay.
Yes.
So thank you, Jeffrey. I think my final comment on this, I think good stuff. I think like all the feedback, I think there's some merits in this proposal. I think the key thing is what you want from IETF is also the key discussion point. We cannot touch the 3GPP system architecture, but if they're for supporting such an architecture, if we need some extensions to some protocol, something, I think that would be a very much relevant discussion. That's one point. And on the technical front, if you look at enterprise private 5G, we have also collapsed functions into a single thing. And in the process, if the control plane is outside, there's certain optimizations. You're absolutely right, right? If those optimizations have to be standardized, again, you need to go back to 3GPP. But yeah, I think more discussions, if you need something from IETF, welcome.
Yeah, a quick response to that. So on IETF side, we do not need any changes. I appreciate this venue here to discuss this, but otherwise I do not need any IETF changes.
Okay, good.
Thank you.
Good to get that. Thank you. All right, next one is this yes? Okay. This yeah, services mobile user plane architecture. Yeah, please go ahead. This is Satoru-san. Yeah. No.
Hello, this is Satoru. I'm present here some update on SRv6 mobile user plane architecture for DMM. On behalf of my co-author from the SoftBank, Arcas, Cisco, Bell Canada, Broadcom, and Intel. So next slide, please. So this is the update from 03 to 04. What we made on this revision was mainly on the illustration section. You can see the old 03 draft. We put just illustration as the one section only, but we structured this illustration section with the 4 subsections. The first one is how to accommodate SRv6 network for the existing mobile network service. Second one is SRv6 map PE deployment at all SR domain egress edges. What I presented in the previous IETF meeting, you can find that. And third one is adding direct segment with new SRv6 map PE. This is also I presented before, so please find that. I included that model in the appendix, right? The last one is corrupt SRv6 map PE deployment. This is a new one, which I'd like to share what that looks like. Thank you. So this is the how the corrupt SRv6 map PE deployment works. On the left-hand side, this is the control plane figure, how it works. So on the control plane side, the map controller receives session information from the mobility management system, and then map controller creates the 2 types of the session transform route for each session. Type 1 for downlink, type 2 for uplink. So all the session transformed route received at the map PE exists on the border between the interwork segment for existing mobile service network and the core side of the map PE is the usual SRv6 backbone, not special. On the remote PE, it's not SRv6 map aware because the once map PE receives the session transform route from map controller, map PE advertise the corresponding route for the UE as a usual L3 BPM net routing information. That's how control plane works. On the user plane view, you can see this. I highlighted only on the map aware PE. Usually, as a deployment model, all of the PE, except the PE connecting to the UPF, need to be map aware. But in this deployment model, the map aware PE only can exist on the side of the interwork segment side in the 5G architecture case, which is the N3 interface. That's how the new deployment model, MAP-P, collapsed MAP-P deployment looks like and how it works. Okay. So next slide, please. So as you can see, we added the deployment model in the illustration section. We will continue to update, make much precise and clarify the how to better understanding. And I think we could reach the certain level of the maturity of this document. So please review it, and if you are interested, please inform us whether it will be time to adopt the other working group document. Okay. Thank you.
Thank you. Any questions, comments on this proposal? Mr. Eric?
Yeah, am I going to have people complaining to me about architectural something about this as well? Yay. Okay. Do we have a plan for addressing?
This is an individual ID, not a working group document.
No.
It's a proposal.
Okay. Is your intention but your intention is to seek adoption?
If it is the right timing, I think we could continue the work in the individual draft. But if we can collect the enough interest, I can ask the adoption of the working group document for DMM.
So on this, I have one question now to Eric. Can IETF make like how Margaret made a recommendation for IPv6 prefix allocations, right? Back in 2012 timeframe or earlier, right, for PDN sessions, right? So in other words, recommending 3GPP to instead of allocating individual IP addresses, do a prefix allocation. In the same manner and fashion, right? Can we publish some of these architectural recommendations? It's not in our scope, but can IETF make a recommendation? Just I'm trying to see a path for some of these work items, right, which we cannot touch, right? But can we make a recommendation if there is consensus?
I mean, I think I could take Joel's point here that it could be informational. Like this is a way you could do it.
Okay.
I don't. I'm not fully aware of all the sensitivities about how 3GPP feels about their architecture. I know that like a lot of people run a lot of different combinations of stuff. Not everybody runs the whole, all of the interfaces and that kind of stuff, right? I mean, there's lots of different deployment models.
Let me clarify the standpoint of this document as an architecture document. The draft currently on the IETF RAS core is the protocol, and under the 5G architecture to be followed, because we follow that architecture and study that protocol under the 5G architecture in 3GPP as well. And then this is the outside of the 3GPP architecture, but this is just plugin. If operator want to use, there's nothing happen unless the map controller receives the session information from the existing mobility network. The rest of the part of the network is totally outside of the 3G, 5G architecture. This is just IETF network for the SR architecture.
So no impact to 3GPP
Yeah.
system. Yeah.
Okay, that was essentially my
But,
question
yeah,
was, does this
yeah.
impact the architecture at all? And we're going to have questions about,
That helps. Yeah, absolutely. Suresh?
Yeah, Suresh Krishnan. So like I'm in like two minds about this, Satoru-san, right? So does it impact the architecture? I think kind of, right? Like because so if you look at Eric, just to give you a brief on the goal of this, right? So this is like more into 3GPP operators rather than 3GPP, right? So the idea is like there's some kind of use cases, like, if you look at like, fixed wireless or something, right, where all the heavyweight stuff is not required. So this is like recommendation saying like, hey, for some of the use cases, like you can do something simpler. Is like what this draft is trying to do. So it's possible that it says like, hey, some of these things are not probably needed for you, right? I think we need to find a sensitive way of saying that, right? But that's what this is. It's saying like, okay, like, if you have like best effort traffic only and you don't need accounting for it, this is how you can do it. I think that's the line he's taking. So whether or not that like impinges, that's something we need to discuss for sure, right? But that is the line it's taking, this can be purely informational. So there's nothing really that needs to happen. So this is using IETF protocols from all. I don't think there's any new protocol development required for this. So.
But Suresh, on that, right, the question is, would 3GPP object to doing this kind of work?
We don't know.
That's the question.
We don't know. It's possible.
Right.
It's certainly
Right.
possible because there is some way saying like, hey, like, but should it happen in 3GPP, right? Because like, I'm sure like 3GPP may be interested in saying, hey, like, for these use cases, maybe this is better. So
Yeah.
I don't know the answer. We cannot answer that up front, but I think like keep the communication lines open. Like Lionel is there, like
Yeah.
Hanu is there. So kind of keep the lines open, and Satoru-san is like in 3GPP too. So like kind of get, I don't know, for like release, I don't know, 19 or something, like, put in a stage 1 for this, right? I don't know, like study item or something, I think would be good to at least go and explore the problem space somewhere as well, like in parallel. Like I don't think it's like needs to stop here to work on this, but yeah.
Thank you, Suresh.
Eric? Yeah, okay, that's it. Okay.
thank you.
So I think the key takeaways, I think as long as we are not touching the 3GPP system, point number 1, generally if it's informational and if there are no major objections, if there are no objections from 3GPP, and if they believe IETF is a good forum to continue doing this work, I think that's something to validate. I think thanks again for the presentation. If there are no other comments, yeah, please.
Interesting work, but from your explanation here, I'm seeing some, I would say, significant impact to the 3GPP process or procedure flow here.
No impact.
Okay, let me explain. Okay. Because when I think Suresh asked a question about, okay, your map controller, and you say, okay, this one has to get some sort of information from 3GPP 5G system. So I'm trying to think, okay, how are you going to get it? And then you can use like the edge computing scenario to give like AF guidance, those type of things. But the thing is to expose some 5G system information to a third party. That is the first thing you have to address. The second one is the things like, I think you have to get a two-way. It's not just like a one-way from 5G to you or your system and your system to 5G here. So I think this type of things, and then suppose you do use some sort of, make your map controller as an AF, and like AF guidance, and then go through the NEF and PCF, those type of things. But the problem here is you have to not just the study item, stage 1, stage 2 is way beyond what you are doing right now here. Because there you have to, like from PCF, you have to at least to tell the thing involved in this picture here, but even if you are not describing like the GNOB part, the UPF, but the thing is they are on the data plane. So I truly, you have to think about that things, especially like from your map controller. How are you going to get those information exposure? That is big, I would say a big story from 5G system. Thank you.
Thank you. I think I would recommend to read the document because the map controller just expose the API. Whether using API or not, totally depends on the operator decision. And then what if the 3GPP want to utilize that interface? that's fine. So just open the interface for who want to this underlying the network and mechanism. Just that.
I can try to answer Change's question. That map controller can run N4 interface to the SM. You can even think of that map controller is the control plane of a traditional central UPF. So he talked that traditional central UPF talks N4 to SMF and then send out BGP signaling messages.
Yeah, it could be whether the entity on the 3GPP side, whether it is UPF, whether it is SMF, it's totally out of the scope of this document.
Still,
I think we have Suresh online. Yeah, next. Oh, you're done. Okay, okay, please.
yeah, so the things like the mob controller, or as Jeffrey explained here, you can make it like just like SML work, also things. But still, the things like you have to introduce that one. I'm not sure you're going to introduce a function as inside the SMF, or you're going to introduce some. I don't think you have any. I don't think you can introduce one network function. The best shot is for the AF part, some trusted third-party AF. But the thing is, as you keep saying.
Okay. Let me clarify. This is actually independent from any specific mobility management system. Any mobility management system can utilize this mechanism. Not depend on just 5G, not depend on just 4G or 3G or 6G. PMIP and other mobility management appeared. All of the mobility management system can see the some plugin option to carry the user plane packet over the SRVC network. That's the idea of this architecture, not to depend on the specific mobility architecture. I understand you want to use this idea for your 5G network. I understand. So please propose that work study item to the 3GPP. I happily work with you on the 3GPP if you want to.
Okay. And I think thank you for that one. I'd like to work with you on that part. Well, by the way, I think Jeffrey mentioned that next week in Toulouse, there's going to be a big meeting on 3GPP. Another part is you keep saying for the mob controller. I think that one is a two-way. It's like you have to get some exposure from 5GS and also you have to tell something to 5GS. So that is something it's very sensitive for that part. Yeah.
Okay.
Thank you.
Thank you. And I don't see any other questions. I think. Thank you, Satoru-san. So, what are the next steps from your point of view, Satoru?
Please let me know if you are interested in. So I want to collect the voice and feedback. Thank you.
All right. Thank you. I think next is media header extensions. John, is it on? Is that am I doing the right one? Yeah. Okay. Okay, this one, I'm also co-author. Maybe Satoru should run this discussion. Yeah.
So this is a new draft on media header extensions for the wireless networks. This has, it has a lot of transport layer impact, but also the architecture is related to the mobile network and wireless in particular. So hence the request for some input or feedback from this group. So if you go to the next page, please. Okay. So this is divided into, I'll divide it into three parts. First, provide the motivation for this. And it's essentially about the latency and bandwidth requirements that media packets have, especially in the wireless network, and the link capacity variation that needs to be addressed. And why the end-to-end congestion control itself may not be sufficient. So there are two parts in this. One is what kind of metadata may be needed to each packet to help the wireless network along. And the other aspect is if this metadata needs to be provided, how will that be transported from the application to the wireless network? So if you go to the next page, please. Yeah. So the motivation for this, I mean, this figure is really showing a couple of things. I mean, one, if you look from the UE to the wireless network, it's showing the change in the rate of that the wireless network provides, and that changes rapidly, much faster than an end-to-end congestion control can signal that change. So in other words, I mean, we think that the end-to-end congestion signal can give you an average rate, but it does not give you that instantaneous rate change that occurs in the order of hundreds of milliseconds and not in the order of maybe half a second or a second. So the network operator then has to either choose to provide it at the lowest level, which would be underutilizing the network, or if you utilize the network to the full extent, then there will be buffer overflows, which if nothing else is specified, it would be random drops. And random drops in a media case, for example, if you have an iframe and it's dropped, what happens is that some congestion signaling will feed it back either via ECN or with RTCP. And then it will resend the iframe, maybe with priority, but all of that is going to increase the load and not improve the situation. Again, it delay and other things are impacted. Just for clarification to the group, the iframe, why the iframe is important is because the other frames that follow, like a P or a B frame, are dependent on the iframe itself. So if that is dropped randomly, I mean, because without any other specification, it's going to be dropped randomly. And that's not a good situation. What we're requesting for is some way to handle this kind of mechanism. And I'll get to that in the next page. But to go to the second bullet now, in 3GPP, for the time being, we've looked at RTP and SRTP, which expose headers which carry what kind of a packet it is, whether it's a dependent packet or an independent packet where it starts and stops. And based on that, you can classify these packets and give information to the radio scheduler to act in a specific way. But once you go to something like HTTP3, all of this information is lost. And I suppose even with RTP cryptex, all of this information is going to be lost, and the scheduler does not have the ability to make any informed decision, and so it's going to do random decisions on dropping. So that's the problem that we face. And so if you go to the next page, we'll cover what kind of metadata we would like to get from the application, and then how we want to transport it also. So, metadata is obviously very sensitive information, and this would be between two trusted endpoints in the wireless network and the application server. So it's not exposed data that's sent, like DSCP or something on the wire. We expect that it will be handled in a secure way and, between the two endpoints. But the main data that is required is not to encode or decode the packet, but rather to handle it in the radio network. And the radio network would perhaps require these three at least, and hopefully only these, the priority or importance level of a packet or a series of packet that belongs to that same group, like an iframe. And I think I mentioned the example earlier itself. So if there's a congestion, even if it is discarded, the application will have to resend it. So that's not a situation we want. And if the network can handle it better to where it is sent in the first place, then the application performance and everything is improved in a better way. So there are these dependencies that an importance that is being addressed here. The second is packet burst. If the scheduler knows how much, I mean, it looks like these are heavy-tailed applications. I mean, the packets arrival rate. So if this information is provided, for example, how big that burst is, then the scheduler can prioritize or change resources to be able to handle that burst in the right way, by it cannot create resource, but it can reprioritize and handle these in a better way. And the last is with respect to delay budgets. If it's known as, some are not delay critical. So since these, the link changes go up and down, it could, reprioritize where some packets that have more of a delay budget is delayed to when the resources come back up again. And during the time when there is only very little budget available, then those with very short time delay are sent along. So those are the three aspects that we think are essential. Maybe there are a few smaller things, but we will have to look at. This is the first version of the draft, and we're looking for feedback from this group too. So if you go to the next page, this is about the transport of the metadata itself. And, there are three options. This is not something we've come up with. This is something that the 3GPP study has looked at. And, there are these three options that look interesting, but each has a problem of its own, or advantages and disadvantages. Media over quick extension. If, for example, if this transport, if the 3GPP network looks as a relay, then, and it also transports this metadata, then, that would be one option. But then this is restricted to HTTP3 data. But, we'd have to deal with RTP and HTTP3. UDP options, on the other hand, will cover all these cases, but then we have to consider how we expose and get this information for the UDP option to transport it along. And then there's mask encapsulation, which avoids the need for major standardization, but then you incur a lot of overhead in terms of the UPF behaving like a proxy and encrypting, creating a mask tunnel and getting it back to just get the metadata. So each of these has some advantages and disadvantages, and we need to find the right trade-off, handle privacy concerns, and make sure that there's a fair way to get this information. But I think what we're finding is that this information would be very helpful, and we're looking for how we can handle this in IETF. This is obviously over the N6 or the IP network to the 3GPP network. And so this is what we're looking for. If you go to the next page, I think I'm only summarizing it. So I think, I think if the problem is essentially to handle those variations in wireless networks and get the metadata, how to handle it with encrypted and non-encrypted media packets, and how to transport that information. Welcome any comments and feedback.
Thank you, John. Any comment? Question?
Hang Shi from Huawei. Do you have any quantitative results that how much improvement can bring to the video QE if you use this kind of advanced scheduler?
Yeah, no, we don't have any qualitative, qualitative information on that. More or less is qualitative information, which is that the current approaches are lacking. There is significant amount of work in 3GPP by various companies, so it's a whole study that's been running for a year, which includes the major, component vendors in RAN, including Huawei, Nokia, Ericsson, and others. So they all are engaged in the discussion and feel the need to do it, and it is being addressed for RTP and SRTP. What we're now bringing up here is how to handle the issue for when you have encrypted information, and then what do? You don't have this. So the metadata that we proposed here is what is being identified in the study. It's not that we've come up with that metadata. It's how to handle it for encrypted packets.
Yeah, I think the problem is valid, and I think it may also apply to the fixed network, not wireless.
Okay.
And I think a general mechanism for this kind of metadata exposing is really useful, regardless of the transport protocol or proxy or not, or the kinds of mechanism. Yeah.
Thank you.
Shri Gundavali, co-author, I think just to comment on this, I think one of the reasons why we are bringing this here is I think 3GPP is doing their study in the XRM study that's very specific to their access. Bringing it here, I think we can potentially apply to other radio technologies and maybe even non-radio technologies. I think potentially, let's say there's a DOCSIS transport, right? If we send this metadata, maybe on the scheduler, maybe how we use this information, maybe we can improve the system. I think that's the theory, that's the thesis. So any feedback would be appreciated. Yeah.
Yeah, Lorenzo Colidi, I think all of this stuff is, I think the kind of the point is that all of this stuff is encrypted. And, if you're proposing that the encryption be made more leaky, then you may have like a sort of an uphill battle, at least depending on who's doing the encryption, right? You've definitely seen people like Netflix get into fights with people like Comcast about, who should drop whose packets and so on, and who should pay whom. So I'm sort of wondering whether it seems like you ruled out anything that acts at the IP layer, but DSCP bits or something like ECN, like moving like specifying ECN for quick, all of that stuff seems like it's a much easier sell because it's outside the encryption. So
right. I agree that there's clearly a problem with how to establish the trust between that's something that we have to handle. What we find that the L4S and other ECN can help, but not to the extent. So we need to find, maybe this is something we need to explore. And to answer Lawrence's question in a little more detail, maybe we can have the application server provide the specific metadata in such a way that it is not leaky. And that may be the challenge. I mean, what is it willing to disclose? I think that's a key part of something we'll have to propose.
Yeah, just I think to Lorenzo's comment, I think is somebody with this metadata, will they be able to correlate the flow? Will they be able to identify the type of flow? I think that's the question. All we are saying is it's an I frame or a B frame or a P frame. What can one possibly do with that information?
Drop all the B frames and cause quality to be bad, if you want to.
if there's a malign
but is that from privacy point of view is an impact?
The point was, and I think one of the points is like establishing trust, right? And if you don't have that trust, but I think that's the point, right? You don't need to establish that trust to use something like DSCP.
DSCP semantics may not be sufficient, but yeah.
Yeah, with DSCP, this is one of the options that 3GPP has proposed, but the trouble is that now the iframes will go over one DSCP, and maybe the others will go over another DSCP, which exposes the same amount of information, really. So if somebody is monitoring, so you're exposing really that information with a lot of additional complexity that comes in. So in terms of the information, there's nothing more really, but that's the
Tianji.
Yeah.
This is a legitimate problem for sure. But if you, since you keep talking about the 5G system as an example here, so I try to understand one thing. You have all the metadata is important. And then you think, okay, suppose you may face some challenge about encryption. So encryption for the data plan. And you have a metadata. The information about your metadata has to be provisioned to the 5G system. So even after that, we'll still be facing the challenge about the encryption. The first. The second one here is like you have all the kind of metadata. And then this information has to be some sort of converted and to be provisioned into the 5G system. Right? So this is legitimate, but I'm thinking how in the background of 5G, how are you going to apply this one?
Okay. So let me take that second part first and say that in the 5G, there's already specific, I mean, not specification, but studies that have reaching conclusion on how to transport that information from the UPF to the radio side. So that's essentially via extensions to either the GTPU header or by using multiple QoS flows. So that part is being handled. It's specific to 3GPP, and that's why I did not bring it here. But it is being proposed, and there are two models currently in contention, and one of them will be picked. But both will provide the 3GPP radio with how to qualify, which flow is more important, and then to prioritize the drops and so on for the RTP and SRTP cases. But now when we come to, as we go forward, we've got to look at this encrypted part, which is what we're looking at here. And you had a question on that, which I may have missed.
Me?
Yes.
No, the thing is here, well, talking about the encryption. So on your GDP, and then if you look at you have the IP, UDP, GDP, and then beyond it, the control plane data has been encrypted. So like, I forget, sorry, Lawrence mentioned about like I frame, P frame, B frame, those type of things. You may be able to sum the RTP extension header to know some sort of information, discardability, importance, but you not be able to look at which one is more important, I, or less important, P, or B, or those kind of things.
Right. Actually, we don't want to be able to decode all of that. So essentially, the scheduler needs very little information. So what you mentioned really, is it discardable or is it independent? Or is it not one of those, So based on that's really the basic information in that importance, really. So which is already there in the RTP headers now, SRTP header extensions rather. So that's the kind of information we want. And also where it starts and where it ends, because we don't want to drop in between. So all of that is already there in the RTP headers now. And if that is available in some way for
yes, okay, we can discuss if you do go, we can discuss next week in Toulouse.
Yes.
Please discuss on the offline. Thank you. Lorenzo.
I'm not sure if the queue was already closed, but I just wanted to point out that you also have a completeness of information problem here, because the people who have the QoE metrics are the people in the server. And so they are going to be the ones experimenting with how to mark these bits. If you give those bit semantics, you're kind of taking away the ability of those folks to experiment with what works best for their users, right? So they may want something that is like kind of deliberately vague, like the SCP or ECN or whatever it is that we want to specify, so that they can actually figure out, optimize for those metrics.
Lorenzo, can I follow up and ask if that would be something that we really realize that applications should be in control of this whole process as to what is important or not, and so on. So I wonder if, without the application's trust and its needs, in conjunction with other control plane mechanisms, like ECN and so on, that would be what is needed. But I wonder if there's a way that we can work that out.
Please continue.
You do have to talk to them. Yeah, it's not, sorry.
Yeah, this is a quick update on I presented this on the cryptographically generated device identifiers on the previous IETF. Just a quick follow-up on this. Next slide, please. Yeah, so I think the key thing that what we are trying to do is can we bring how we have an AI in 3GPP in IETF, what we have standardized. Now is a user identifier, right? If you look at network access identifier, it's an identifier used by the access network. Now, in the same manner and fashion, can we bring a structure and some semantics for device identification? I think that's the proposal. If you look at the 4281, right? I think, yeah, that's the one along the same lines. Next slide, please. So let's talk about the use cases. Today, if you look at the identifiers that are present on the device, there is on the interface level, you have a MAC address, you have at the device level, you have a serial number or IMEI or PEI in the 5G system, or on the cellular subscription point of view, there's a IMSI or SUPI. But the question is, which one can be used it as a device identifier? I think that's the semantic that is missing. So we clearly have use cases where, we need to come out with a format and structure. That is one thing. And also, I think we want to bring in some cryptographic relation, because I think there's some threat related issues around that. So next slide, please. Yeah, I think if you look at the use cases here, right, I typically in enterprise, I have my enterprise NI, and case one, I may bring in two devices, an iPhone and iPad, but if the identity is the same, now how can the access network, apply any device specific policies? I think that's the semantic that is missing, right? Earlier, there was an extensive use of MAC addresses, but with RCM, with MAC randomization, you don't have that identifier anymore, right? So now the question is, what is the alternative to that? The other use case is, let's say enterprise has both 5G and Wi-Fi. I can do in handovers. Now, if I bring in two devices, how does the device know that, yeah, it's still the same user, my identity is the same, I'm using the same identity credentials, but what is my device identifier so that the network can perform whatever handovers or permit the handover or do session continuity thing, right? So again, we need some semantic for device identification. Next slide, please. Another aspect to that is, if you look at the GDPR rules, I think, let's assume we use some stable identifier with somehow, let's say we use IMEI as a stable identifier. But the thing is, with the GDPR rules, now I don't want to expose the same identifier in every network, right? Potentially, because somebody can do traceability. So now the question is, can we come out with a structure and semantics where the identifier has a relation to the access network? Next slide, please. So I think the proposal here is coming out with a structure and semantics where the device identifier is generated based on some cryptographic terms, right? Maybe there's a public key, private key pair, and we use some access network identifier and some auxiliary parameters. Based on that, can we come out with a structure? That way, the identifier is a binding to the access network. That is, that way, when I present that identifier to the network knows, yes, I'm able to, I know that this identifier is for this network, and I can identify the device. So this is, the thinking here. I think I see applicability potentially maybe useful in many environments. One more slide and we close it. Yeah, I think the identifier generation, how we generate, and what are the elements that we use for the identifier construction. And finally, should be able to signal this in radius and extensions and other things. All right, we define some identifier for that, some attribute, radius attribute. These are the thinking here. Next slide, last slide potentially. Next slide, please. Yeah, and how the network validates the identifier. I think, that also I talked about it. So I'm trying to see if we can publish some document here along the lines of NI document. So any questions, comments? Yeah, that's all I have. Yeah.
Thank you. Any comment, question, clarification?
Yeah, if there's any feedback, happy to take it. But yeah, otherwise, yeah.
Lionel?
Yeah, thank you, Lionel. Yeah, it's just a question. Time to time, you need the device identifier to be able to perform some configuration update and so on. So in that case, if you are using something that will be encrypted, so how you will, time to time, you will have to de-encrypt it, or?
So the identifier is generated based on some cryptographic key pairs. I think that's one thing. But the access network will be able to, access network has the device identifier, right? It's able to decode that. I think see, the key thing is the endpoint can assert that I'm the owner of the device identifier because I have the private key associated with that. And the network can validate it, yes, you're the true owner of that. Currently, in the IMEI, if I signal I'm IMEI, some other device signals IMEI, there's no way to validate for the network to say, yeah, you're the true owner of that IMEI. I think this is fixes that semantic.
So yeah, so it will be only between the device and the access network.
Access network.
Thank you.
How about the SUPI, those type of things, and then that have been allocated by the operator to the UE, those type of things I haven't seen you mentioning here.
SUPI, you said?
Yeah. Yes.
Yeah. See, SUPI is a subscription identifier, right? Now the question is, if my device has both the radio technologies, Wi-Fi and private 5G, is SUPI the identifier that I can use on the Wi-Fi link or something else? I think that's a question, right? SUPI is so very much specific to the SIM card, right? So yeah, that's why something independent of one layer above might be the right thing. Yeah, yes, Lana.
Yeah, SUPI is more related to the user. And here, so from the mobile point of view, it will be the IMEI. And actually for the SUPI, we have already a solution to be able to encrypt the SUPI.
Yeah, exactly. The SUPI to SUKI is already there, right? Yeah. So, okay, thank you.
Thank you. So next one, Jeffrey.
All right, so this is a presentation I didn't get to do last time because of glitch in uploading the slides. Next slide, please. The use case actually started here about mobile user plane transportation. So in 5G, between the CU or GNOB and the UPF, there is this GTPU tunneling, N3 tunneling that is over an IP VPN. We refer to that one as N3 VPN in this document. The IP VPN is used so that a converged transport infrastructure can be used for both N3 and all kinds of other transportations. So I have a picture here. We have the N3 VRFs on the PEs for the N3 VPN. The GNOBs are kind of like a host in the VR, connecting to the VRFs. The GNOBs put on the GTP header, UDP header, IPv6 header, and gets to the N3 VRF. And then depending on whether the transporter is MPLS based or SRv6 based, we put on a label stack or SRv6 header, plus the original IP header, UDP header, and GTP header. Gets to the other end, the PE removes the label stack or SRv6 header, you get the IPv6 header, UDP header, and GTP header. Finally gets to the UPF. That's how traditionally it works. Next slide, please. So this is what we call the MPLS or SRv6 transporting GTP. The draft SRv6 mobile user plane, that draft is basically replacing GTP with SRv6. And based on the N4, N2 signal GTP parameters, that is under the hood, does not require 3GPP changes. And that replacement could be between the network functions, like between GNOB and UPF, or it could be just between the gateways attached to those functions. In the gateway case, the N3 VPN PEs are natural gateways to do that. So the GP traffic is reconstructed by the N3 VPN PEs. So the source PE replaced that IPv6 UDP and GTP header with the SRv6 header, or vice versa. This is acceptable and preferred by some operators, and they accept this because all the elements are under their own control, so they are fine with doing that. The advantage of this is that you get the traffic steering capabilities for SRT or SFC purposes, and you also get bandwidth savings because you no longer need the IPv6 header, UDP header, or GTP header anymore.
Jeffrey, John from FutureWay, just a clarifying question. So I guess this explains all the routing aspects, all the aspects that are carried in the GTP signaling, like QoS aspects and so on, are covered, I mean, I suppose,
yeah,
right?
This is basic what that IETF last call draft is about, right? So I'm just explaining yeah. So this is about SRv6 replacing GTP. And as I show in this picture, I want to point out another option for the MPOS operators. If you're not using SRv6 and if you want to continue to use MPOS, you can do similar things. So here you replace that SRv6 header with MPOS label stack. That's all. You still get SRT, SFSA, a benefit that SRv6 replacing GDP gives you. Additionally, you can get even more bandwidth savings because you only need a simple label stack instead of the entire SRv6 header. So that's basically MPOS replacing GDP. Essentially, this is a pseudo wire between the GNOB-CU and UPF, and that only transport the payload of that, just the GDP payload, basically. Yeah. So in the SRv6 replacing GDP case, the TEID and other GDPU parameters are put into the SRv6 header. But in the MPOS replacing GDP case, we leave the GDP header in place. We just replace the IPv6 header and UDP header with an MPOS label stack. Next slide. So that's the basic idea. It was originally written as a pseudo-wire draft, but then we generalized it to the entire the IPVPN. There are a lot of details in the draft about signaling, but I'm going to skip it here. I just want to mention this option of replacing GDP tunneling under the hood with MPOS, similar to using SRv6 to replace that. Again, it's under the hood. I think I'm just going to stop here, skip the rest of the slides. Yeah.
Okay, that's it, right? Yeah. Thank you, Jeffrey. Any questions, comments on this? Yeah, please. Who is it?
No matter what, replace GTP with either SRv6 or MPOS. I haven't read your draft yet. How about those like the IE information element that embedded in the GDP, like a PDU session container for the QoS flow, all kind of information regarding, that be carried within the beyond the GDP header. Thank you.
In the MPOS case, the GDP header is kept and GDP payload is kept, so nothing changes. In SRv6, I believe most of the parameters are placed into the SRv6 there, so it should be fine, but I don't know the details there.
Okay, question? Yeah, please state your name, please. Yeah.
Hello, Tim Costello from BT. Could I ask if you've had liaison statements exchange with 3GPP, the CT groups at all?
So I used the word under the hood several times. So basically, there is no change to 3GPP architecture or signaling. We are still doing this based on the N2 and N4 signaling. So because of that, I didn't think we needed this liaison because this is all under the hood. So it's just the operator deployment choice.
Okay, thank you.
Okay, last question, yeah.
I have a follow-up question regarding the liaison part. You keep mentioning about the end of the hood, the underlay part is like transparency to the upper layer here. Regarding the GDP, I'm thinking for the TID part is okay. How about the end divide, the IP for the both ends? For that things, are you going to embed it in your like SRv6 header or MPOS label? Those type of things, or just you go through the control plane, you get them from SMF, AMF, those type of things, and then program into SRv6, MPOS, those type of things?
Right, N2 and N4 signaling still happens as is. That's the key.
Yeah, so in that case, so what is the difference here? You just run IP, UDP, GDP with the underlay SRv6.
Right, so you can either do SRv6 or MPOS transport GDP, or you can do SRv6 replacing GDP or MPOS replacing GDP or under the hood.
Yeah, exactly. But what is the, because you have to do the mapping here. You have the QoS flows, those type of things through SDAP on G-node for the uplink. But the downlink, you have the things originally, the UPF will do the in-cap for the GTP. Now you have to add additional functions. I'm not sure it's necessary or not, but you have to add those things in order to incorporate these things inside, either the GNOB side or the UPF side.
Even in the original SRv6 or MPLS transport GTP case, you still need to translate that cross things into the IP or MPLS cross mechanism in the underlying network. That part, no matter what, it needs to happen.
How about the IE, the GTP IE information element, all kind of things that have been defined in 3GPP?
It's transparent. It's if it needs the underlay work to do something, that part will still happen.
Okay, well, anyway, but still back to my original question, like, so in that case, why you want to add another things beyond the already existing?
It's not adding another thing, it's
Let's take it to the list. I think, thank you so much. Yeah. Yeah, okay, all right. I think this was our last presentation. That's all. We close the meeting here. Thank you so much.
Thank you.
Okay, that's good. Thank you. You're getting recorded. That's it. Okay, no touch.
Yeah. Wait, we should write it to see.
Fine. I guess you're joining tomorrow.
Yes.
How was the DMM? I think it was okay. My introduction will be fine.
It's okay.
See you over there. Okay. I have almost.
Good to see you.